today is 12.4, Permutations and Combinations. The essential question is, what is the difference between a permutation and a combination? We have 3 new vocabularies. The first one is factorial. The factorial symbol is the exclamation point. So you notice that for factorial it says n factorial, which means the number of ways that you may arrange n items. So you're using all of the items, it's how many different ways you may arrange them. The next new vocabulary is a permutation. A permutation, in our book, the symbol is capital P, and then in parentheses, you have n comma r, and those are, the n and the r will be replaced with numbers. Where n is the total number of items that you have, and r is the number of items that you're using. So it's different from a factorial because in a factorial, you're using all of your items. So in a permutation, you're using some of them. The order that you use them matters though. The order matters. So for example, a locker combination, the order matters that you turn the dial to do your combination for your locker. Any kind of password, username, like for using a computer, anything on the internet, those usernames and passwords, the order that you enter them in always matters. So when order matters, it's a permutation. The numerator, the top of the fraction, you see is just n factorial. So the number of items you have, that factorial. But the denominator, you subtract your 2 numbers, n minus r, and then take the factorial, and then you'll actually divide your fraction at the end to get your answer for how many different ways you could arrange them. A combination, the difference between the combination and the permutation is, in the combination the order does not matter. So you are selecting a group. So for example, the combination capital C and then n comma r for the notation. The n is also the total number of items.
Corey, could you please call extension 6801? Corey, 6801.
So the n represents the total number of items that you have, and the r is how many you're going to use in your group, and the order that they're selected doesn't matter. So if you have a group of, say, 5 selected out of 10 students, and they're all going to have the same task, it isn't going to matter what order you selected those 5 students out of your 10. The denominator on the combination, you have the n minus r factorial, and then it's multiplied by r factorial. So you have to make sure that you solve the entire denominator and that you divide your fraction at the very last step. Hopefully this will make sense when you see a couple of examples. Okay, solve the factorial. Lloyd and 5 friends go to a movie. In how many different ways can they sit together in a row of 6 empty seats? If you have 6 empty seats, there are 6 people that could sit in the first seat. Now in the second seat, because one of them has already sat in the first seat, there are going to be 5 people left, then 4, 3, 2, 1. So if we multiply all of these together, we get 6 factorial. Because a factorial means that you're multiplying together all of the whole numbers, starting with the number that you have the factorial for, down to 1. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And on your calculator, the PRB button on our calculators that we use in class is where you can find the symbol for the factorial. You have to enter the number first and then push the PRB button. And then on my calculators, you have to push the arrow over 3 places to find the exclamation point and then push enter. And then push enter again, and it gives you the answer, which is 720. So instead of multiplying it all out by hand, there's a key on your calculator that you can use that makes it a lot quicker. If you don't have a calculator like this at home, I'm sure you can search online, like calculators.com, and use an online calculator. So 6 people sitting in 6 empty seats, we're using all 6 people. So it's just 6 factorial. The next example, how many different batting orders can Tommy's coach make if there are 12 players on his pitchball team? Well, all of the players get to bat on the pitchball team, so you're using all 12 players. So it's simply 12 factorial. 12 factorial, we could multiply out 12 times 11 times 10 times 9 and so on. Or we can just use our calculator and enter in our factorial, and it gives us this fantastically large number right here. So 479,001,600. That's how many different batting orders Tommy's coach can make for the 12 boys on his pitchball team. I'm pretty sure that if you were reading the problem and you were taking a multiple choice test, I'm pretty sure that without using a calculator, you would never guess that it would be a number that big. Your estimate, I am certain, would be much smaller than that. So please make sure that you are using a calculator and that you are actually calculating your factorials. All right, next we've got permutations. Permutations, sometimes you see written a little bit different than this. So I'm going to show you a notation that you may see in a different textbook, just because it could be written either way. So instead of with parentheses, you might see the capital P, where they have the number 7 written to the left of it and the number 2 to the right of it. Either way, we're going to plug it in our formula for a permutation that you wrote in your vocab. So n factorial divided by n minus r factorial would look like this. Now, I am going to subtract 7 minus 2 and rewrite it as 5 factorial. 7 factorial, using my calculator, is 5,040, and 5 factorial is 120. If I divide those, I get 42. Now, let's say that you were solving a problem like this and you didn't have a calculator. I'm going to show you how you can do this without a calculator. 7 factorial. Looks like this. 5 factorial. Looks like this. So you may notice we know how to work with fractions. We know how to reduce. If you see the same number in the numerator and the denominator, they cancel each other out. Common factors. So look what happens. 5 factorial cancels out all of the 7 factorial except for 7 times 6, which is 42. So without a calculator, you should be able to figure out that factorial by using a little bit of cancellation, reducing your fraction first. Another thing that you might think about is if you start with 7 items and you're just going to fill the first 2 spots, there's 7 for the first spot, 6 for the second spot, also equals 42. So a couple of different ways you can think about that permutation. Now remember, permutations are when the order does matter. When the order does matter. The next one, I would have 9 factorial and then 9 minus 3 factorial, which is 6. So 9 factorial divided by 6 factorial. Use my calculator. $362,880 divided by 720 for 6 factorial. My answer is 504. Again, if you think about my shortcut, if we wrote out 9 factorial, as soon as we got to the 6, it would cancel out everything on the bottom. So all of these would be canceled out, and it would just be 9 times 8 times 7, which is 504. So permutations, order matters. Order matters. So with the 7 and the 2 up here, you might think about a race where you have 7 people running in the race, and there are prizes awarded to first and second place. Down here, maybe you have 9 people in the race, and prizes are awarded for the first 3 places. like in the Olympics, gold medal, silver, bronze. So order does matter. The next two are combinations, and combinations are when order doesn't matter. So a word for combination that you may see is like group, that's used frequently. Like if you have 6 people, how many groups of 4 could be selected? And this formula has 6 factorial on the top because we have n factorial, and then n minus r factorial on the bottom times r factorial. So the denominator is a little bit more complicated, So 6 factorial is 720, 2 factorial is just 2, 4 factorial is 24. You need to multiply those together before you do your division. Remember that calculators do not always calculate things in the order that you would like them to. So in order to get the correct answer, you want to make sure that your denominator is a single number. So 15, there are 15 combinations. So remember, this one, order does not matter. So these 4 people that are being selected, they're going to be doing the same thing. There isn't anything special about being picked first, second, or third, or fourth. Either you get selected or you don't. One more combination. So this one we'll have 5 factorial, and then 5 minus 2 factorial times 2 factorial. 5 factorial is 120. 3 factorial is 6 times 2 factorial, which is 2. So my denominator is 12. If I divide, I get 10. So there are 10 groups of 2 that you could choose from 5 items. Another thing to think about with combinations when order doesn't matter would be, let's say that you are ordering a pizza and you call in and let's say that they had like 5 different toppings you could choose from, and so you're just gonna say like, you know, how many different 2-item pizzas could be ordered? There's 10 different 2-item pizzas that could be ordered if there were 5 toppings. The order doesn't matter typically with something that you're ordering like pizza, frozen yogurt, ice cream toppings, something like that. Or if you're picking out groups, like at school, if you're doing Battle of the Books and there are 5 books that your group has to read and everyone is going to read 2 of them, it wouldn't matter what order you read your 2 books as long as you read them before the test. Okay, now this last one, we've just got 5 different examples. We just want you to think about if you think it would be a combination or a permutation. Because what happens is on your homework and your tests, some of them will tell you, they'll give you the word permutation or the symbol for a permutation or for a combination, but others are word problems where you have to be able to read it and figure out what type of situation you think it is. So, the question that you should be asking yourself is, does the order matter? Does the order matter? Because if the order matters, it is going to be a permutation. It's going to be a permutation. So up here on this list, the 2 that order matters would be the locker combination and the internet password. The other ones, the order does not matter. Does not matter. If you're pulling something from a bag, it doesn't matter if you're putting toppings on ice cream, and it doesn't matter if we're pulling names from our U-Rock container because there's the same prizes for all of you to choose from. It doesn't matter if your name is pulled out first, second, or third. What would actually matter is when you come up to get your prize, what we have left in the cafeteria, and that has nothing to do with the order that your names were pulled out of the container. Okay, now you should be able to write a summary, and in your summary, think about answering that essential question and saying more than just the basic. So we want more than just the word order. And here are your homework problems. Please make sure that you use a calculator for those factorials if they're really large.